So now that we got a little bit of understanding of the measurements and different types of Greek prefixes representing numbers, now let's get into the idea of accuracy, precision, and significant figures. So we basically have three terms here that we kind of have to kind of walk through. Let's start with accuracy. And accuracy is basically is how exact one can measure a specific quantity. Accuracy is really dependent on the instrument that is being used to measure the quantity. So I could have, basically two scales. Scale 1 and scale 2. And if I weigh, the same solid object. On one scale, I get a value of 10.34 grams. And then the other scale, I get 10.3387 grams. Here we see a difference in accuracy. Scale on the left is less accurate. It can basically measure to the 100th place. While on the right, scale 2, we have something now that is more accurate, since it can measure to the 10,000th place. So here we have two measurements. Just one scale is more accurate than another because of its ability to go into, basically more digits, essentially. So if we look at those two measurements, there are what I like to call known values and an approximation. If we go back to our examples of scale 1 and scale 2, scale 1 had the 10.34 grams, while scale 2 had the 10.3387 grams. So when we look at these digits, the first three of scale 1 are known, that we actually know that it's 10.3 grams. And even if this is a digital scale, that last digit that we have here is really an approximation. Same thing with the other scale, but notice that there's a lot more digits that are known. We can go all the way over to the thousandths place, and then we finally get to the last digit, which is the approximation. So we could say that scale 2 is more accurate since there is a greater detail in the known digits. Another example that might make this more clear would be to look at maybe two rulers. We have ruler 1 and ruler 2, and we're trying to make a specific measurement. So here's our ruler 1. Let's say this is in inches. Right, we would have 0 on the far left. We would have 1.0 on the far right. And so we're using the same, style of ruler for each 1 and 2. But ruler 2 has more hash marks, or, more ways to define measurement. So maybe something that looks like that, and something that looks like that. So just have basically a rough measurement with our ruler. And we're going to measure the same exact distance. So here is our distance. We're going to measure the same distance for each ruler. And if we go to ruler 1, we could say, for certain, I have 0.5 inches. And we also know that it's less for each 1 and 2, but ruler 2 has more hash marks, or, more ways to define measurement. So maybe something that looks like that, and something that looks like that. So just have basically a rough measurement with our ruler. And we're going to measure the same exact distance. So here is our distance. We're going to measure the same distance for each ruler. And if we go to ruler 1, we could say, for certain, I have 0.5 inches. And we also know that it's less than 1.0 inches. So that's the idea of, kind of the known value. And now we go to an approximation, meaning that, well, I know it's greater than 0.5. It's, at least 0.5 inches, but it's a little bit more than that. And then I could approximate and say, well, I think it's 0.51 inches, where here is my known digit or value, and then we also then have the approximation. So that's about as far as I can go with using that specific ruler. With the ruler 2, I also know it's 0.5 inches. I know it's past that, but I know it's less than 0.6 inches. And that's just because there's a greater level of accuracy within this ruler. I can measure quantities much more specifically. So if I come down, I could say, well, I know that it's 0.5, but looks to me like it's more than 0.55. And so now I can go to another level of accuracy where I know these two values, and now I'm approximating the third, saying that, oh, I know it's really close to 0.56, so I know that I'm past 0.55, and now my 8 is the approximation. So that's the idea of accuracy, is that accuracy is very dependent on the tool that's actually used in the measurement. The greater level of ability in terms of measuring, the greater level of accuracy that's actually there. And that's what significant figures is really describing. Significant figures basically indicate how accurate the measurement is. The greater number of significant figures, the greater the accuracy. So when we always look at a value, let's say of a measurement, there's always going to be what we were just talking about. There's always going to be digits that are known or defined. And then that last one on the end is always an approximation. Even if you're doing this digitally. So that's the idea of significant figures, and then the relationship to accuracy. Precision is basically how reproducible are the measurements by the instrument. So we can go back to kind of a scale example representing scale 1 and scale 2. And we take 3 different measurements of a piece of material. First scale, we get 10.01, 10.00, and 10.01 grams for those 3 distinct measurements of the same material. And for the second scale, we get 10.05 grams, 10.10 grams, and 10.00 grams. There's not much difference here. This scale is more precise, reproducible in terms of these results that we're having. While on the right side, right, this scale is less precise, not reproducible. Results. And one thing to note is that both scales have the same accuracy, since they measure to the same number of significant figures.